Hello, Dr. Allen here again. This is our second part on our series on fats. There are two families of essential fatty acids. The omega-6 and the omega-3 fatty acids are called essential because our bodies are not able to make these fatty acids. Omega-3 fatty acids can be found in flaxseed, pine nuts, walnuts, fish, and certain plant oils. Linoleic acid is an omega-6 fatty acid. It is found primarily in seeds, nuts, grains, and legumes. Prostaglandins are a part of a class of substances called iconosands. Iconosands influence numerous metabolic activity, including platelet aggregation or blood clotting, inflammation, hemorrhage, vasoconstriction, vasodilation, blood pressure, and immune functions. This here is a slide on icosands. We've seen this slide before on our last talk on fats. We see on the left side of our screen the omega-3 fatty acid families, and on the right side of our screen the omega-6 fatty acid families. We start out with the omega-3, or alpha-linolenic acid, and on the right side it's linoleic acid. They sound pretty similar. There is an N in linolenic in the omega-3 family. When we go down the chart on the omega-3 fatty acid family, we come down to the important omega-3 fatty acids, which are the EPA and the DHA. The EPA makes anti-inflammatory prostaglandins, and the DHA is needed for structure formation in the cells of the brain. On the right side, we have the omega-6 family, and the important thing to recognize is the arachidonic acid there. And the arachidonic acid, if you look at the pink box near the right side, you see the heading above, which says it's more inflammatory. So that's the trouble with the omega-6 fatty acids, is they can make arachidonic acid, which can make inflammatory prostaglandins. This is another chart of linolenic acid, and we can see how it progresses down the structure, adding longer chains of carbon until we get to the arachidonic acid. There are different enzymes that are needed to make this process go. The arachidonic acid is not all bad. It does have some function in stimulating muscle growth at times. Some arachidonic acid is in the outer phospholipid layer of each muscle cells. With the stretching of muscle fibers during exercise, arachidonic acid is released and metabolized to a prostaglandin. Arachidonic acid is the chemical messenger released by your muscles during intense weight training, which causes minor trauma to the muscle tissue. This trauma triggers the inflammatory prostaglandins, which trigger muscle growth and healing. Post-exercise muscle soreness tells you your inflammation is involved in the healing in this microtrauma. If your primary concern is muscle gain, arachidonic could help as long as you're consuming enough omega-3s in your diet also. However, if you suffer from one of many inflammatory conditions that plague many people who exercise, tendinitis, bursitis, arthritis, etc., then you should probably stay away from it since it can be pro-inflammatory. If you have or at a risk for diabetes, asthma, high blood pressure, high cholesterol, heart disease, or other inflammatory disease, you should not supplement with arachidonic acid in your diet. The major dietary source of arachidonic acid are beef, lamb, pork, egg yolks, dairy products, chicken, shellfish, and organ meats. These foods are considered inflammatory. Unsaturated fats. They are less stable and more chemically active than saturated fats. This is a picture of a triglyceride. Triglycerides are composed of 3 molecules of fatty acids attached to a glycerol molecule. We have here an example that has a saturated fat at the top, which means there is no double bonds. A monounsaturated fat in the middle, which means there is one double bond. Mono means one. And on the bottom, it has 3 double bonds. This is a polyunsaturated fat. In this case, it's an omega-3 fatty acid because it comes at the 3rd carbon, starting at the omega end. You see the small omega at the right side of your chart. A little basic chemistry. A double bond means there's a sharing of electrons. Here is an example of an unsaturated fatty acid. The double bond is in the 9th position here and is the common position for the unsaturated fatty acid that you find in olive oil. Interestingly, the reason why the omega-3 and omega-6 fatty acids are considered essential is because animals cannot insert any double bonds before the 7th position, starting at the omega end. Plants can insert double bonds at the 3 and the 6th position, so we need to get these from plants. This is a discussion here of competing enzymes in the omega-6 versus the omega-3. These enzymes, the 3 listed here, desaturase elongases, cyclooxygenase, lipooxygenase. A low omega-6 diet, meaning low in omega-6 oils, leaves more enzymes to process omega-3 into DHA, which is needed for the brain, and more conversion to the low inflammatory prostaglandins. So this is one of the reasons why it's good to eat a low omega-6 diet. In other words, avoid vegetable oils that are refined and fried foods. The omega-3 fatty acids, like the omega-6 fatty acids, are linolenic is pictured here with the omega end, and you count 3 bends in. The bend is where a carbon would be till you get to the omega-3 position, and the alpha position is on the other end. You can call things by the alpha position, such as we see the 9, 12, and 15 would be considered, this would be considered alpha 9, 12. This linolenic acid would be considered alpha 9 and omega-3, just for that nomenclature. This is a picture of oleic acid. This is a monounsaturated fatty acid. We see the cis and the trans position. The cis is the normal position. If they get damaged or heated, it can go into a trans position, which makes them straight rather than curved, so they act more like a saturated fat than an unsaturated fat. Monounsaturated means they only have one double bond. The monounsaturated are more chemically stable than the polyunsaturated fatty acids, such as omega-3 and omega-6. Oleic acid is found in olives, nuts, and avocados. Here we see the chemical structural drawing of a saturated and unsaturated. This is the actual chemical structure. We can see in the unsaturated omega-3 fatty acid, we have a double bond. Here in this chemical structure, just to try to understand how the structures are, we have a double bond in the omega-3 carbon position, and we have only one double bond, so it's called monounsaturated. Linolenic acid here in the different chemical structures as it is processed by the enzymes. Eventually we come down to the second from the last, arachidonic acid, which can be inflammatory and is one of the important things we need to understand about linolenic acid. Here is a slide of the dietary fats. A few are marked, and I'll just briefly go over them. Safflower oil is a fairly good oil because it has 77% monounsaturated fat, which is considered one of the good fats. And flaxseed also is a good oil. It has 57% omega-3 oil. The omega-3 and the omega-9, which is the monounsaturated fat, is felt to be the best of the fats, whereas the saturated fats would be considered the worst of the fats, relatively speaking. The omega-6, although it is an essential fat, we try to limit the amount of it because it can be inflammatory. We're going to discuss nuts at this point. This is a chart of the different kinds of nuts. I listed them in the order that I classified them as the healthiest nuts. Chestnuts I put at the top of the list because they are only 0.3% fat by weight. Pine nuts are the second best because they are the highest in the omega-3 fats, which we do need. Walnuts are the second highest in omega-3. Hazelnuts are good because they have the highest amount of the monounsaturated fat in them and a fairly low amount of the omega-6 fats. They're 79% monounsaturated fats. Almonds and pecans are also fairly high in the monounsaturated fats. Macadamia nuts are unusual in the fact that they have a omega-7 fat at the highest level at 18%. However, the macadamia nuts are fairly high in saturated fats. Brazil nuts and cashews are also fairly high in saturated fats. That's why they're down lower in the bottom of the list. And peanuts, although considered mainly a legume, is fairly high in saturated fat at 19%. And they have a relatively low amount of the monounsaturated fats and relatively higher amount of the omega-6 fats, and they don't have any omega-3 fats in them. So just in summary, on nuts, all nuts are considered healthy. People that eat nuts 3 times per week live longer, according to the Adventist Health Study. Nuts are a good source of fiber and vitamins. Hazelnuts are highest in monounsaturated oil at 65%. Pine nuts are highest in the omega-3 fatty acids at 19%, with walnuts being second. Here is a slide that shows some of the benefits of omega-3 fatty acids. They help decrease our lipids, they reduce inflammation, and they decrease our risk of blood clots by decreasing platelet aggregation and increasing hemostasis. Some of the other benefits of omega-3 fatty acids is they're an improvement in the lipid metabolism by reducing circulating triglycerides and the remnant lipoproteins, which are an independent risk factor for atherosclerosis. They participate in the synthesis of anti-inflammatory mediators that, together with the promotion of vasodilation and regulation of hemostasis, improve vascular function with a cumulative vascular protection. Omega-3 fatty acids have other beneficial actions, as mentioned, and they help maintain healthy skin, equalizing weight, and other benefits. Monounsaturated fat, oleic acid, found in olive oil, nuts, avocados, and some other oils, reduce this hormone called NPY, a powerful appetite-inducing hormone expressed in the hypothalamus. This decreases hunger, is not inflammatory like omega-6 fatty acids and saturated fats, is more chemically stable than the polyunsaturated fatty acids, does not raise LDL cholesterol. Structure can change with frying, and in a trans double bond position, it acts more like a saturated fat and could have some inflammation. It does, however, add to the overall fat burden if somebody has ongoing obesity or lipid toxicity. Polyunsaturated fatty acids, omega-6. Summary: in excess are inflammatory, is damaged with frying, is an essential fatty acid. In other words, your body cannot make it and it does need some of it. We should avoid these oils in refined forms, such as corn oil and soybean oil. Refined oils. Avoid all refined oils. The micronutrients in nuts, seeds, and plants are needed to keep oils from becoming lipotoxic. Saturated fatty acids. They cause inflammation, insulin resistance, and inflames the hypothalamus, causing a dysfunction in weight and appetite, leading to obesity. They raise LDL cholesterol and contribute to atherosclerosis. They should be avoided. They're mainly found in animal fats. Coconut oil. This is a slide showing the different kinds of saturated fats in coconut oil. Coconut oil is 88% saturated fats. Low uric acid is the main part of the saturated fat group at 49%. It does have some of the monounsaturated fat, but it doesn't have any omega-3 fats and very little omega-6 fats. Lauric acid makes up 47% of palm kernel oil and 42% of coconut oil. Lauric acid is a medium-chain fatty acid. It raises cholesterol significantly. This is largely due to the increase in HDL cholesterol, which may be beneficial. It is not as inflammatory as the long-chain fatty acids such as palmitic acid. The conclusion on coconut oil is not as harmful as animal fats, but would only be considered beneficial if eaten in the natural form, i.e. in a coconut. If you must fry food, which I do not recommend, coconut oil is probably the safest oil for frying. Here is a picture of the cell membrane. The cell membrane, as you can see, consists of a phospholipid bilayer, which is composed of fatty acids with a hydrophilic head and a lipophilic tail, which means that the lipids tend to stick together and the heads would prefer to be on more of the side where there's liquid, such as inside and outside of the cell. So they make this phospholipid bilayer. Here we see the hydrophilic head and the hydrophobic tail. This is what's called a phospholipid. Cell walls are more stiff if they're mostly saturated fats because they pack tighter. They're more fluid if they're mostly unsaturated fats. Saturated fats increase low-density lipoprotein cholesterol. High levels of LDL cholesterol have been associated with increased risk of cardiovascular disease. Saturated fats are stable at high temperature, unlike polyunsaturated fats. That's why saturated fats like butter, lard, and shortening are solid at room temperature. This is a picture of cholesterol. You can see it's altogether different from a fatty acid. This is a picture of a lipoprotein. It has a phospholipid monolayer covering it with triglycerides and cholesterol inside, and there is a protein wrapping around that works as a receptor. This is a slide showing the various pathways that fats come in and are taken out of the body. It comes in through the intestines, in through the liver, and are changed to lipoproteins, transported throughout the circulation where it's needed, stored in fats if required. Here we see the process that causes atherosclerosis. We see that LDL cholesterol enters through the endothelium and can become oxidized, and an oxidized LDL is taken up by macrophages, and these form large what's called foam cells, and these can grow into plaques and eventually rupture. The platelets also can cause problems if they form a clot on the surface. You can see the HDL is beneficial and it helps get rid of some of these saturated fats, and it has other benefits in reducing inflammation. Here is a picture of a atherosclerotic plaque. We see the problem with the atherosclerotic plaque is it's plugging the arteries, and it can rupture and completely plug the artery. Causes of inflammation: a high-fat diet, especially saturated fats, bacterial, viral, or fungus infections, chronic low-grade food allergies or food sensitivities, an imbalance in the bacterial fungus in your gastrointestinal tract known as dysbiosis, stress and depression, environmental toxicity, high sugar diet, constant dehydration, lack of sleep. Inflammatory causes: inflammation causes vascular disease such as heart attacks, strokes, aneurysm, or amputation. It causes also cancer, arthritis, multiple sclerosis, ulcers, lupus, Alzheimer's disease, and many other diseases. Endothelial cells are essential for maintaining vascular health, and they need to be healthy. Which is worse, a sudden or a slow blockage of an artery? A sudden is worse. It causes a rupture. In fact, a rupture of a 30% blockage is worse than a 95% blockage, because a blockage that is blocking 95% only has 5% of the blood flowing through, and there's probably some collateral circulation helping supply the muscle with blood. But if you have only a 30% blockage and this ruptures, this takes away a 70% flow and can cause a sudden drop in blood flow to a vulnerable muscle and can cause a worse heart attack than if your 95% artery closed off. A soft plaque is worse than a hard plaque. Here is a picture of the endothelial cell. We see the endothelial cells are on the surface, and under the endothelial cell there's an elastica endometria, and under that is smooth muscle cells. The endothelium, or endothelial cells, lines on the inner surface of the blood vessels. The vascular smooth muscle cells are just below these cells. The endothelial cells maintain the vascular tone along with the smooth muscle. The endothelial cells regulate the inflammatory response and homeostasis and thrombosis. Impairment in the endothelial cells cause atherosclerosis and other vascular diseases. Nitrous oxide is a regulator of the arteries along with prostaglandin I2 and also endothelial-derived relaxing factor. Nitrous oxide also regulates platelet aggregation. Endothelial dysfunction causes abnormalities in vasodilation and vasoconstriction. It precedes the development of atherosclerosis. Inflammation. Many studies have found that inflammation is the root cause of coronary artery disease, obesity, and diabetes. Inflammatory cytokines. Elevated level on inflammatory cytokines such as tumor necrosis alpha factor, interleukin I beta, interleukin 6, and interferon gamma were observed in endothelial dysfunction. These are all inflammatory activators. Saturated fatty acids are largely responsible for atherosclerosis. Saturated fatty acids increase low-density lipoprotein, which is a major risk factor for cardiovascular diseases. Saturated fat. The length of the saturated fat affects the risk for causing atherosclerosis. Palmitic fatty acid is the greatest risk. Short-chain fatty acids and medium-chain fatty acids are not as much risk. Palmitic acid causes inflammatory response by activation of toll-like receptor 4 and NLRP3. Inflammasomes. Inflammasomes are cell receptors of the innate immune system responsible for activation of the inflammatory response. NLRP3, an inflammasome, is activated by palmitate from the saturated fat palmitic acid. This activation suppresses the insulin receptor, resulting in insulin resistance. NLRP3 activation by the saturated fat palmitic acid is the best characterized inflammasome that correlates with a number of human diseases, including atherosclerosis, cancer, and neurodegenerative diseases. Here in this slide, we can see that obesity and insulin resistance, which is caused by long-chain fatty acids and chronic high glucose level, leads to glucotoxicity, and glucotoxicity leads to amplification of the prostaglandins that lead to inflammation, and they lead to beta cell dysfunction, which leads to diabetes. The beta cells are in the pancreas, which produce the insulin. The way fatty acid causes endothelial dysfunction is the saturated fatty acids trigger inflammation in the endothelial cells, which trigger receptors, reducing nitrous oxide production. Also, the saturated fatty acids elevate the ET1, which causes vascular constriction. Saturated fatty acids can also activate the apoptosis pathway, which may cause beta cell death. A dose-dependent increase in ROS, reactivate oxidative stress, is seen in monocytes exposed to free fatty acids, which leads to adhesions of the monocytes to the endothelial cells. This is a critical mechanism in the development of atherosclerosis in the early stages. There is also evidence that the renal angiotensin system is activated by free fatty acids, and this renal angiotensin system causes hypertension. Leukocyte activation is deleterious for endothelial health. Free fatty acids can also activate leukocytes and contribute to the adhesive properties of leukocytes in the angio-2-dependent manner, leading to the onset of endothelial dysfunction. Basically, the leukocytes are white blood cells which are harmful to the endothelial cells, and they're activated by activation of the Ang2-dependent manner, and this can be done by the saturated fats. Endothelial progenitor cells participate in the endothelial recovery following arterial injury, and factors such as oxidative stress contribute to the dysfunction and apoptosis of the endothelial progenitor cells. So what this is saying is the endothelial progenitor cells, these are the cells that will make new endothelial cells that line the blood vessels. When the blood cells are damaged, then the repair process is inhibited by saturated fats. Dysfunctional endothelial progenitor cells are thought to be a key regulator in the pathogenesis of atherosclerosis and other cardiovascular disease. Palmitic acid, which is the most abundant type of free fatty acid in the circulating blood, contributes to cell death of the endothelial progenitor cells. Circulating forms of omega-3 and omega-6 fatty acids sometimes contribute to oxidative stress and inflammation. It is not completely feasible to conclude the idea of taking more omega-3 and omega-6 rich food is healthy, although omega-3 fatty acids are generally anti-inflammatory. Inflammation means in Latin ignite and set alight, is part of the complex biological response of vascular tissue to harmful stimuli such as pathogens, damaged cells, or irritants. Acute coronary syndrome. The first step is enzymes thin the fibrous cap over the plaques eventually. Pressure of blood flow causes plaques to rupture. Thrombogenic events result in a blood clot in the artery. Downstream, heart muscle is deprived of oxygen, which leads to acute coronary syndrome, or what we call a myocardial infarction. Here is a picture of this acute coronary syndrome, where you can see a rupture in that thin coating, the endothelial cell, and then we see it forms a thrombosis, which is a blood clot, and this closes off the blood circulation. So which is worse, a sudden or a slow blockage? Sudden is worse. As we've discussed before, closing off a large artery is worse than closing off a small artery that's 95% narrowed already. A soft plaque can rupture easier than a hard plaque. Low-density lipoproteins. LDL cholesterol, or low-density lipoproteins, migrate into the endothelial space where they become oxidized. Monocytes, or circulating white cells, travel to the endothelial space where they become macrophages. They uptake this oxidized LDL cholesterol and convert the macrophages into these large phloem cells that cause the atherosclerotic plaque. The LDL particle size is important. The small, dense LDL particles is what causes the atherosclerosis. A large, buoyant LDL are too large to enter the endothelial cells and are not atherogenic. If triglycerides are high, i.e. above 200, and HDL is low, i.e. below 40, it is likely that the LDL particle size is small. If the triglycerides are low, below 150, and the HDL is high, which is above 50, it is likely that the LDL particle size is large, buoyant type. Cystokines, as we mentioned before, these cystokines and is the name used to describe a diverse group of signaling molecules. Some of them are necessary to initiate an inflammatory response necessary to recruit monocytes. Protoglycans. Under atherogenic conditions, macrophages release protoglycans, which can contribute to cell-mediated formation of aggregated LDL, a potential inducer macrophage foam cells, which are the hallmark of early atherogenesis. Things we can do to reduce inflammation. Reduce our LDL cholesterol. Reduce oxygenation of LDL. Reduce cytokines. Reduce protoglycans. Reduce T cells. Reduce monocytes. Increase HDL. So how do we do this? By avoiding saturated fats, eating anti-inflammatory foods, fruits, vegetables, nuts, and whole grains. Avoid pro-inflammatory foods, fried food, processed foods, sugary food, fatty foods, and vegetable oils. Exercise is beneficial. Water is beneficial. Sunlight, vitamin D, beneficial. Avoid toxins. Fresh air is good. Adequate sleep is important. Avoid stress and depression. Reducing LDL cholesterol. This is done by a diet that's low in saturated fats and low in cholesterol. Also, medications can help if absolutely necessary, includes the statins, Welchol, or the herbal remedy red yeast rice. Reducing oxygenation of LDL. We do this by eating dark green vegetables, berries especially, fruits and other vegetables. Nitrous oxide deserves some attention. It seems that the nitrates themselves are relatively inert until they turned into nitrites by bacteria in the mouth or enzymes in the body. These nitrites are key players here. They can either turn into nitrous oxide, which is good, or the nitrous amine, which is bad, which we will cover in detail shortly. Nitrous oxide. Nitrous oxide, NO, is an endothelial-derived relaxing factor. It prevents cellular elements in the bloodstream becoming adhesive. It's the strongest vasodilator in the body, prevents inflammation from forming on the wall of the arteries. Adequate amount of nitrous oxide prevents the formation of plaques and can destroy foam cells. Nitrous oxide. Data shows ability of endothelial cells to produce nitrous oxide declines by 50% between the ages of 25 and 50 years of age. However, gastrointestinal tracts can also produce nitrous oxide through the consumption of nitrates such as kale, Swiss chard, spinach, arugula, beet greens, and beets. When chewing nitrous mixed with bacteria in the crypts of the tongue, they become converted to nitrates. Once swallowed, gastric acid reduces nitrates to produce nitrous oxide. Nitrites become converted, then reabsorbed downstream into the circulation and circulate 10 to 20 fold after traveling back to the salivary glands. As a person chews additional food, saliva contributes nitrites that get converted by gastric acid into nitrous oxide. So in summary, the best way to get this is by chewing and by eating green vegetables. A word on nitrous amines, so we won't become confused on the different kinds of nitrates and nitrites are frequently added to processed meats like bacon, ham, sausages, and hot dogs. They function as preservatives and help prevent the growth of harmful bacteria. When nitrites are exposed to high heat in the presence of amino acid, they can turn into a compound called nitrous amines. There are many different types of nitrous amines, and most of them are potentially carcinogenic. They are among the main carcinogens in tobacco smoke, for example, because most bacon, hot dogs, and preserved meat tend to be high in sodium nitrates. They are a high protein food, a source of amino acid. Exposing them to high heat creates the perfect condition for nitrous amine formation. A way to increase our HDL is by exercise, especially aerobic exercise. Normalizing immune system means normalizing our T cells, normalizing our monocytes and macrophages, deactivating the protoglycans and the cytokines. This is done by a low-fat diet, adequate vitamin D levels, teeth in good repair, avoid foods that you're allergic to, avoid chronic infections such as yeast, viral infections, etc. Healthy gut flora, good bacteria likes good food. Avoid stress and depression. Exercise or conditioning exercise significantly reduces pro-inflammatory markers in your body. In addition, those volunteers who exercise vigorously were 45% less likely to have high vitamin C reactive protein levels than their sedentary peers. Water is important. Water flushes toxin and other irritants out of the system. Dehydration causes sickness. Chronic dehydration causes inflammation. We should at least get 2 quarts of water a day. If you're sweating much more, if your work or lifestyle prevents you from getting adequate water between meals, take it with your meals. We should avoid toxins, tobacco, alcohol, and drugs. Sleep is important. Whenever you chronically skip on sleep, the inflammatory state is unbalanced. Blood levels of C-reactive protein and anti-inflammatory marker used by medical professions to produce risk of heart disease, and general inflammation goes up when sleep is too short for a prolonged period of time. We have thus shown the benefits of a low saturated fat diet and fruits and vegetables and avoiding harmful fats. There was a confirmatory study which was called the NHANES. It was an abbreviation for United U.S. National Health and Nutrition Exam Survey. There was 24,825 participants. They found that those on the low carb, high protein, high saturated fat, sometimes called the Atkins diet or the ketogenic diet, had a 32% higher risk of all-cause death over an average of 6.4 years of the study. Deaths from coronary disease were increased by 50%. Death from cardiovascular disease was increased by 50%, and death from cancer was increased by 35%. Saturated fatty acids block the inside part of the insulin receptor, blunting the effectiveness of insulin in the liver and muscles. Therefore, when you eat carbohydrates, you need more insulin to keep your blood sugar down. Some cells are not designed to take in extra fats, such as the liver and muscle, and this causes a fatty liver and can affect the muscles adversely also. So, in summary, here's some recommendations. Chew and swallow dark green vegetables every day. The more the better. There are studies that a cup of pomegranate juice daily helps reduce inflammation. Omega-3 oils daily in the form of walnuts, flaxseed, or cold water fish is helpful. Never take an unnecessary antibiotic, but take it if you need it. Avoid inflammatory foods such as refined grains, soda, red meat, processed oil, sugar, fried foods. Exercise daily. Sleep well. Think and speak positive thoughts. And repair or pull your bad teeth.